Okay, we talked about exponential functions already, so let's go ahead and talk about logarithmic functions. So a logarithm is really just an inverse of an exponential. So if you look at the graph, and I have a logarithmic function here, it's going to look something like that. So my logarithmic function is going to look something along those lines, and then you have your y equals x line, and your exponential function is going to look something like this. So underneath Chapter 4 info in our Tri-State page, it has a picture of this basically where your exponential function is up on top here that you're looking at, and your logarithmic function is the one that's down on the bottom. They are inverses, so they flip over. That y equals x line in this instance is blue. Good, and along those same lines, this is the formula for a logarithmic changing to an exponential. Okay. So this just means y is equal to log base a of x, and then that is equivalent to your exponential of x is equal to a to the y. So your answer for a logarithm is actually the exponent of your exponential. So when you actually do a logarithm, what you're going to do is you're going to take your base a, go toward the equal sign and around. So a to the y equals x. And that's the same thing you have over here. A to the y power is going to equal x. And that's the conversion. Those are equivalent. You can take an exponent, put it into a logarithm, put it to an exponent. Let's try a couple of those. Okay, so here's our first one. Log base 2 of 8 equals 3. So I'm going to take my base 2, bring it around, and then have that as my answer. So this is the same thing as 2 to the third power equals 8. And does it? Yeah! 2 cubed is 8 all day long. So it's the exact same thing. Pretty cool, right? Let's do some more. Okay, check this one out. Log, and the base here is 1/2 of 16 equals -4. You do the exact same thing. You take your 1/2, bring it around to the equal sign and to your answer. So 1/2 to the -4 power equals 16. Pretty cool, right? Now, let's look at this for just a second. Anything to the 1/2 power, anything to the negative power, this 1/2 is actually going to be flipped. So it makes it 2 to the -4. So 2 over 1, whenever you flip the inside of your fraction, it makes the exponent positive. Is 2 to the 4th 16? All day long, baby. Okay, let's do another one. Check out this super awesome thing. So you try this one. I'm going to give you just a second. Convert this one into an exponential. All right, cool. Check it out. So you start here at your base of an exponent, your base of a log, same thing. Come around, and then you come up with your answer. So you actually have 5 to the first power equals 5. Does it? Yeah, and check this out. Anytime you have the base and the number next to it are exactly the same, you know it's going to be to the first power here, because in order to get the same base and the answer, it has to be to the first power. Cool. Try this one. Okay, take a look at that. I put a fraction in there to try to freak you out, but just remember, it's not freaky. Just make the conversion using the fraction where it belongs. Yeah, do you see that? Okay, cool. So you have 3/4 as your base. You're coming around to the equal sign, and there it is. This is 3/4 to what power? 0. That's okay. Because what happens when you have to the 0 power? What do you always get? You get 1. Good. So anything to the 0 power is 1. That means over here on this side, if my exponent is 0, you're always going to have 1 as the answer there. Pretty cool, right? All right, let's look at these logarithms a little bit deeper. Now we're going to use what we know about logarithms and make the conversion here so that we can solve for x. So I don't know what x is. I have to try to figure it out. And anytime you're given a logarithm, you want to turn it to an exponential because we can then work with an exponential. Okay, so let's try this thing on for size. We start here with the x. We go toward the equal sign and around. So this is really x to the 3rd power is equal to 8 over 27. Now, how do I get rid of that 3rd power? Yep, cube root. So I'm going to cube root this side, cube root this side. So x is actually equal, what's the cube root of 8? 2. What's the cube root of 27? 3. Good. So you just solved for x. X is 2/3. Not too bad, right? Let's try another one. Okay, let's try this one on for size. The x is in a different place, but we're still solving the same way. You start with your base, you go around towards the equal sign, and you get your answer. So this is really 4 to the 5/2 power is equal to x. So anytime you have a fractional exponent, what does that actually represent? A radical. Cool, so change it to a radical. Remember, it's power over root. So it's 4 to the 5th power, and the bottom number means square root. So the square root of 4 to the 5th power is going to equal x. What's the square root of 4? 2. So 2 to the 5th power is 32. You got it. So x is equal to 32 in this instance. X can either be our base, as we saw in first example. It could be over here to the answer, as we saw in the second example. And lo and behold, the very last thing we're going to do is whenever it is what it is equal to. Let's try that one right now. Just like those other two problems, the first thing we're going to do is make our conversion. If this is log base 49 of the cube root of 7 equals x, let's do work on this thing. So we're going to take our base 49, bring it around. So 49 to the x power is equal to the cube root of 7. Now, look at what we have here. Just like what we did in the previous section, you make your logarithm into an exponent because we can solve those. We've worked with that. Anytime you have an exponential where the variable's in the exponent, what's the first thing that you try to do? Get like bases. You're right. Let's do it right now. What is a like? Well, first, before we do anything else and get too crazy, how can I rewrite that cube root of 7? So I really have 49 to the x is equal to 7 to what power? How can you write the radical as a power? 1/3. Good. Good. So the cube root of 7 is the same thing as 7 to the 1/3. Now this looks a little bit nicer to get like bases. So what's my base going to be in this problem? 7. So I end up with 49 as a like base will be 7 squared. So it would be 7 to the 2x is now equal to 7 to the 1/3 power. So as soon as you get like bases, ditch them and write your exponents equal to each other. Divide both sides by 2. Dividing by 2 is the same thing as multiplying by 1/2, and you end up with x is equal to 1/6. Pretty cool, right? Because logarithms and exponentials deal in exponents, anytime you have a radical, the very first thing you want to do is change to an exponent. And then you can work with it. Awesome.